Hello everyone. Isn't this the case for you? When you can't find what you want, or when you lose luck at an important time, etc. I always think like this every time.
Are their odds really right?
As you know, there are different probabilities. For example, on the previous screen, you can get the highest rare at 3% in gacha, or the moving can be hit at 80%. But you can't rely on probability only when you're aiming like this, can you? So in this video, I actually measured the probability. In this measurement, I use Pokemon. The reason, it is realistically impossible to keep spending money on gacha, because we have to increase the number of trials in measuring. And this is how it's measured. I will prepare a typical movings of each accuracy rate. I prepare a typical movings of each accuracy rate of 100, 90, 80, 70, 50%. I shoot these movings 100 times at Pokemon on Road 1 for each moving and measure the accuracy rate. Of course, we eliminate all uncertainties except the accuracy rate of the moving. Now we come to the results and the consideration. We will use the results to consider the credibility of Pokemon probability. The above is the result of this verification.
Do you feel this is a margin of error?
I think it is unreasonable to feel that this difference is an error. The reason is that Pokemon's accuracy rate is originally set in increments of 5%. In other words, I think the margin of error should be within 2 to 3%. Even if you estimate too much. However, the result was a margin of error of up to 5%. So why the error? Now let's look at random numbers in a program. Here is one example of a program that generates random numbers. So will the program give you a number between 1 and 100, 1 for each of 100 tries? In terms of results, the answer is no. This is up to 100 divided into 4 parts and output how many times it came within each range. If 1 to 100 were output once each after 100 actuations, then each value should all be 25. But when you look at the results, you see a bias in the numbers that are output. For convenience, probability means that if you go 100 times, you only need to hit that number. For example, if you set the probability at 75%, and if the number is less than 75, you win exactly 75 times if the numbers from 1 to 100 are output 1 at a time. But with this random number, you will hit 81 times. In other words, the probability in the program has to change from how many times out of 100 it hits to the perception that a random number less than that number hits when output. So even if you do it 100 times, it doesn't mean you can hit as many times as you do. In fact, increasing the number of trials doesn't seem to be exactly stochastic. Whether you consider 57 out of 10,000 as a margin of error is honestly up to you. Personally, after 10,000 attempts, I'd like to see the odds come true. Well, one of the interesting things about probability is that it doesn't go according to probability. How was it? You might want to take this opportunity to be a little concerned about the odds around you. Thank you for watching.